Finite Math, Chapter 7, Section 7, the Simplex Method, Non-Standard Problems. Okay, first of all, we're going to look at the simplex method with non-negative variables and mixed constraints. In other words, up till now our variables have had to be positive. That's changing. And now our constraints don't have to be less than or equal to. They could be less than or equal to, equal, or greater than or equal to. We need to remember that the right side of the inequality must always be non-negative. It must be 0 or positive. So if that's not the case, then you'll need to multiply both sides by a -1 to achieve that. But remember, multiplying both sides of an inequality by a negative means you must reverse the inequality sign. The constraints still need to be written as equations. But now that we can have either less than or equal to or greater than or equal to, we're going to have to make a slight change. For constraints involving less than or equal to, add a non-negative slack variable. This is exactly what we did in the last two sections we talked about. Here's the difference. If we have a constraint with a greater than or equal to, then what we need to do is subtract a non-negative surplus variable. And we're still going to use an S with a subscript. This variable, it's the same idea as the slack variable. Because we're converting a greater than into an equals, it's possible that there was actually more there than what we're saying it equals. So we add in a negative, we subtract a number to make up for that surplus that's there. Okay, let's try this. Restate the following problem in terms of equation, and then we will write its initial simple tableau. Pause the recording to try this, and then resume the recording to check your answer. All right, so notice what we've done here for our constraints is for the first one that was greater than, we subtracted a surplus variable, and then for the second and third constraint, we added a slack variable. We've also noted on the bottom that all of these variables are non-negative. The next thing we'll do is we will change our objective function so that the right-hand side is 0. We need to rewrite the objective function, subtracting everything off of the right side, and then use that with our constraint equations to write our initial tableau. Notice we're omitting the Z column as before. Now, because we have a negative on one of our slack or surplus, actually a surplus variable, this is something else we need to think about. This was not a concern with maximization problems that we did earlier, but now that we're getting into different types of constraints where they involve greater than and less than, we need to consider this. So we're going to look at this, and we need to see if there is what is called a basic feasible solution. In other words, if we were to set all of the non-basic variables, which would be x1, x2, and x3 equal to 0, would we get solutions that are usable? And the answer is no. Remember, our variables are supposed to be non-negative. Well, taking out the non-basic variables, we have that negative S1 equals 8. Well, that's a problem because that means that S1 equals -8. And our slack and surplus variables, all these variables are supposed to be non-negative. So we do not have what is called a basic feasible solution. If we did, then we would do what we've been doing. We would do just like we've done in sections 5 and 4. However, this is not a basic feasible solution. So we actually need to do 2 stages to our problem-solving process. And the first stage is going to be to make sure we have a basic feasible solution. Okay, here are the instructions. If any basic variable has a negative value, locate the -1 in that variable's column and note the row it is in. In the row determined in step 1, in that row, choose a positive entry other than the one at the far right and note the column that it is in. That's going to be the pivot column. Use the positive entries in the pivot column, except for the adjective row, to form quotients and select the pivot. then we'll pivot as usual. And we'll do that as many times as we need to until every basic variable is non-negative. This is just stage one. Once we get that taken care of, then we will use the process that we did in sections 5 and 4. Kind of broken this down by the steps. So here's our initial tableau. And we're going to locate the -1 and note the row, and then choose a positive entry. So there's the row with -1. And I'm going to use the entry at the far left, the positive one there, and that's going to be my pivot column. Could I have used the 4? Yes, I could have used either 4, but I chose to use the 1. Now we use the positive entries in that column, and we divide just like we've done before. And we get that 1 divided by 1, or 8 divided by 1 is 8, 6 divided by 1 is 6, 22 divided by 3 is 7 1/3. So it looks like our pivot row is going to be that second row, and the 1 in column 1, row 2 is going to be our pivot. Now this is actually kind of nice because it's already 1, which means I don't need to multiply that row by anything. I can go straight into pivoting. So I am going to be multiplying -1 times row 2 and adding row 1, -3 times row 2 and adding row 3, and 4 times row 2 and adding row 4. And when I pivot, I get this. And again, I need to check and see if I have any basic variables that have a -1 instead of a 1, and I do. And it is the fourth column in there. So we're going to need to do this process again. So we're going to have to repeat steps 1 through 4 again on this process. There it is. There's the culprit. All right, one more time. All right, so what I did here was I chose to use the 1 in that row, my first positive or non-negative entry, and I divided by the 1 and the 3 at the end. I didn't divide by the -5 because you don't divide by the negatives. Now, this is interesting because we actually have a tie. They both equal the same thing. When there's a tie, you get a choice. And since my choice is between 1 and 3 to use, 1 or 3 for my pivot, I'm going to use 1 because that means I don't have to multiply by anything and I can go straight into pivoting. So I'm going to use the 1 as my pivot. And I'm going to be multiplying row 1 times -3 and adding it to row 2. I'm going to multiply row 1 times 5 and add it to row 3. And I'm going to multiply -2 times row 1 and add it to row 4. And looking at my basic variables, I can see that I do now have what's called a basic feasible solution. I'm not done. I have completed stage 1. Now I need to complete stage 2. Stage 2 is where I am actually going to find the pivot and do the process that I used in sections 5 and 4. So column 3 is going to be our pivot column because it is the most negative number. It's the only negative number on the bottom row. And when I divide, I get 1 and I get 1.17. So that means the 2 in row 1, column 3, is going to be my pivot. And I'm going to be multiplying that row by 0.5. And after multiplying by 0.5, I then need to pivot. And again, remember, we are talking about row 1, column 3 is our pivot. So we're going to multiply row 1 by 4 and add to row 2. We're going to multiply -12 by row 1 and add to row 3. And then 2 by row 1 and add to row 4. And we get our final tableau. We have no more negatives in the objective row. We are done. So reading off of here, we see that x1 is going to be 4, x2 will be 0, x3 will be 1, and our maximum z will be 22. Now we're going to look at minimization problems. Now for minimization problems, we're going to use a W rather than a Z for our objective function. And our variables are going to be y1, y2, y3, etc. for the variables for our objective and for our constraints. Now the problem-solving process is going to be the same, so that's the good news. Now think about it this way. The minimum value is the opposite of the maximum value. So what we're going to do is we're going to set Z equal to negative W, and then we're going to use the maximization process, and we'll look at how this works. Now don't forget that the constant in the constraints must be positive. So if you need to multiply the inequality by -1 to make that happen, remember that whenever you multiply both sides of an inequality by -1, you must reverse the inequality symbol. All right, let's take a look at this example. We have an objective function to minimize, and we have some constraints. Now, what we're going to do with our objective function is we're going to change it from minimizing to maximizing. And to do that, what we'll do is we'll actually just change all the signs. In other words, it's kind of like we are finding the most negative. We're finding the opposite of the maximum. If that's a little confusing, then just remember, when you minimize, what you're going to do is you're just going to change the signs on all the coefficients. So that's the first thing that we do. Now for our constraints, remember, we want our constant to be positive. So in the first constraint, it's less than or equal to -4. We don't want that. So we're going to multiply both sides by -1. But notice that when we did that, it didn't just change the signs, it changed the inequality symbol from a less than or equal to a greater than or equal to. So those are the two things that you need to keep in mind when we're doing this. Now we convert the constraints to equation by subtracting the surplus variables, and then we set up the first tableau, and there we have it. Now, the basic solution gives us one of our variables equal to a negative. Actually, two of them. The two surplus variables are equal to negatives, and we can't use that. So we need to go through stage 1 until we can have a tableau with a basic feasible solution. So in the column of the negative basic variable S1, there's a -1 in row 1. We're going to choose the first positive entry in that row. So column 1 will be the pivot column. And the quotients 4/1 equals 4, 6/1 equals 6 show that the pivot is the 1 in row 1 in column 1. So in other words, go through the process that we've already learned and then pivot. And when we pivot, we get this tableau. And so we have pivoted. Now, you may have to go kind of back and forth here, but you'll notice in the tableau that we got, we still don't have a basic feasible solution. So we're going to start this all over again. And when we find where the -1 is, we go across that row. And the first positive entry in row 2 is in column 2. And so that's going to be our pivot column. We check the quotients and we find that the pivot is the 2 in row 2, column 2. And then what we've done here is, this is actually the result, this tableau, of the beginning of the pivot where we make that pivot number 1. So we multiplied row 2 by 1/2, and that made our pivot 1. Remember, the pivot is the row 2, column 2, and now it is a 1. And then we're going to pivot in our calculators, and we're going to end up with the result that's below that. And when we look at that, the good news is our basic variables now have positive results, which means that we have completed stage 1, and we are now ready to continue with stage 2. And stage 2 is the maximization process that we learned, the simplex method, in sections 4 and 5. So we're going to go run through that whole process. And remember, we're going to do that until there are no more negative indicators. And the indicators are the numbers in the bottom row not including the number on the far right. The number on the far right can be negative, and indeed, since we're trying to find a minimum, wouldn't be surprising. All right, so we go through and we pivot, and we get our final tableau, which is the one on the bottom there after our pivoting has been concluded. And we see that we have no more negative indicators. Our basic variables are y2 and s2. So y1 is 0, y3 is 0, s1 is 0. y2 is 4, and s2 is 6. Now the maximum value of z is negative w, which is negative 4. In other words, negative w equals negative 4. So w equals positive 4. So the last thing we're going to do is we're going to actually change the sign on that, since we were doing a minimization and we had changed the sign in order to work a maximization problem. I know this is a little weird, it's a little confusing. Give it a little practice and know you can do this. Okay, equation constraints. One more little monkey wrench to throw in here. What if your constraints aren't inequalities? Well, what we'll do is when our constraint is an equation, we're actually going to convert it to two inequalities. For example, a equals b can be written as a is greater than or equal to b, and a is less than or equal to b. Because when those two things meet, you end up with a equals b. So every equation that is a constraint, you're going to rewrite as two inequalities, one greater than or equal to, one less than or equal to, and those two inequalities will take the place of that single equation. So if our constraint is y1 plus 3y2 plus 3y3 equals 6, we're going to write y1 plus 3y2 plus 3y3 is less than or equal to 6, and we're going to write y1 plus 3y2 plus 3y3 is greater than or equal to 6. Okay, so here's another example. Now we're throwing everything at you just about. We've got a minimization, we've got a negative as the constant in one of our constraints, and we've got an equation. So pause this recording and see if you can make the necessary changes and resume it to check and see how you did. Okay, so the first inequality, remember what we're going to do is we're going to make that into negative w, which is going to be z. In other words, we're going to put a negative, or we're going to switch the signs on all of those coefficients on our objective function. And then we're going to need to multiply our first constraint by negative 1, which means we have to flip the inequality around because we don't want a constant that's negative. And then our second constraint is actually going to be split into two constraints because it's an equation. And then we convert them to equations. We subtract our surplus variables from the first two inequalities, and we add a slack variable to the third. And here we have our first tableau. And again, notice we have two negative basic variables. S1 would be negative 4, S2 would be negative 6, which means we're going to have to do the two stages. So you're going to have to go through the stage 1 method of finding a pivot and doing this until we have a basic feasible solution, which means that none of our basic variables are going to end up being negative, and then we will go through the whole simplex method and pivoting. Okay, I think this is saying pretty much what I just said. We choose, let's see, we're going to work with the basic variable S1 because it has a negative 1, and we're going to choose the first positive entry. So column 1 will be the pivot column, and after doing the quotients, we're going to find that we're going to use row 1, column 1, and when we do our first, our multiplying, or excuse me, our first pivoting, here's what we get. Well, that took care of one of them. Now we've still got a negative in S2. All right, so we have pivoted again, gone through that whole process, and we have this tableau. And now notice our basic variables, which are y1, y2, and s3 are fine, no more negatives. So now we need to go through stage 2, which is what we've been doing since section 4. It looks like it's going to be column 5, that's our pivot column, and then we need to find the quotients and pick our pivot row. Okay, applying the simplex method. Fortunately, we only need to do one round of pivoting. When we do that, we get this tableau. So our minimum value of W, which is negative Z, is negative 7, which is 7. So our minimum value is 7. That occurs when Y1 is 3, Y2 is 1, and let's see, Y3 is 0. If you want to count the slack variables and the surplus variables, S1 and S3 would both be 0, while S2 would also be 0. Okay, this is the problem-solving process for the non-standard problems. I'm going to just let you read this, pause the recording if you need to, and then resume it when you're ready to move on. Okay, let's look at another example. We have a college textbook publisher that has received orders from 2 colleges, C1 and C2. C1 needs 500 books, C2 needs 1,000. The publisher can supply books from either of 2 warehouses. Warehouse W1 has 900 books available, Warehouse W2 has 700. The cost to ship a book are as follows. So from Warehouse 1 to College 1, it's $1.20. To ship a book from Warehouse 1 to College 2, it's $1.80. From Warehouse 2 to College 1, it's $2.10, and from Warehouse 2 to College 1, it's $1.50. How many books should be sent from each warehouse to each college to minimize the shipping costs? All right, so we're going to let Y1 be the number of books shipped from Warehouse 1 to College 1. Y2 will be the number of books shipped from Warehouse 2 to College 1. Y3 will be the number of books shipped from Warehouse 1 to College 2. And Y4, the number of books shipped from Warehouse 2 to College 2. And then College 1 needs 500 books, so we know that Y1 plus Y2 equals 500, which is a constraint. We only want 500, so we're going to split that into 2 inequalities. Y3 plus Y4, the College 2 needs 1,000, so again, we're going to split that into 2 inequalities. We know that Warehouse 1 has 900 books available, so we know that Y1 plus Y3 has to be less than or equal to 900, and Warehouse 2 has 700 available, so Y2 plus Y4 is less than or equal to 700. And what they want to minimize is shipping, so we will multiply the price of shipping for each of those by the different variables, as you see there. Okay, now see if you can take this information and get it organized as we need in order to start solving this problem. Pause the recording to do that and resume it to see how you did. Wow. Yeah, I know. This looks just really super intimidating. We got a lot of holes here. This would almost be better to do on graph paper so you could keep everything lined up. But this is what the whole thing is going to look like. Remember that Z is going to equal negative W. We're going to have looks like 2 surplus variables, and then we're going to have 1, 2, 3, 4 slack variables. Notice we've even got spaces where there are missing variables, and we need to keep that all in line. There we have the tableau all set up and ready for us. We do have 2 variables, 2 basic variables that have negatives, so we need to go through stage 1. So start the stage 1 process. If you want to work with S1, you notice the first positive variable in that row is Y1, and go through the process of selecting your pivot column and your pivot row. Okay. And it mentions here stages 1 and 2 could be done by hand, but because it's so large, we definitely want to use technology. Now, the reason that they're showing this as 2 separate screens here is you've seen it on a graphing calculator. It's going to take up more than 1 screen, so that's why this is kind of split up. So they did stage 1, and it took 4 rounds of pivoting and to get our feasible solution. And so let's see, that's what we have here. We have our basic feasible solution here. And then you're going to do pivoting with this, and it'll take 2 rounds of pivoting to get the final answer. And let's see, there is our final tableau. The optimal solution is when Y1 equals 500, Y2 is 0, Y3 is 300, and Y4 is 700. And that gives us a minimum shipping of $2,190. Okay, the rest of these are just some practice problems. Give them a try. Pause the recording to do that and resume the recording to check your answer.